Hello, welcome back to Social Data Analysis. We've dealt with an introductory lesson to R, so I'm certainly sure you have a hang of R programming now. I wanted to zoom into regression analysis, so I'm bringing you a new series on Introduction to Regression Analysis. As a data analyst or as a quantitative researcher, you want to make predictions of a particular outcome variable based on its relationship with some explanatory variable, or you want to be able to make some causal inferences and test a theory, right? And that's what regression analysis is for. So we're going to zoom into that. This lesson will need some basic understanding of ggplot2 and dplyr. I introduced you to ggplot2 and dplyr when I taught data frames. So if you don't know how to use ggplot2 or dplyr, you can check out my video on data frames too. It gives you an introduction. But as we go through this lesson, I'm going to bring you more on how to use ggplot2 and dplyr whilst doing your regression analysis. So let's zoom in into the lesson, and I'm excited about how much you're going to learn with me here in social data analysis. Please subscribe. I really appreciate that a lot, and I'm going to be bringing you more content, so you want to know when I drop new content. Also like and comment about the video. Let me know what I can do better. All right, let's get into regression analysis. So what is regression analysis all about? Regression analysis is mainly about making predictions about the relationship between two or more variables. And secondly, regression analysis is about causal inferences. So you want to be able to predict the values of a particular outcome variable based on the relationship it has with another independent variable. Or you want to make causal inference. Causal inference here means that you want to say that due to the relationship between two or more variables, we can make some claims, or we could build a theory about how these two variables relate, or we could explain a particular outcome variable based on how the explanatory variable behaves. So two things: we want to make predictions and we want to establish causal inferences, and mostly we do that through building theories. So in regression analysis, what we want to do is we want to build a model using statistics that will help us to understand the relationship between an explanatory variable or some explanatory variables and an outcome variable. We want to be able to predict the values of the outcome variable based on how it varies with the independent variable. Regarding the types of regression, there are mostly two types of regression that we're going to cover here. First of all, we're going to deal with linear regression. So with the linear regression, we are dealing with an outcome or dependent variable that has numeric values. So we can expect that there's a lot of variation between values in the dependent variable. Regarding logistic regression, we are interested in a dependent or outcome variable that has just logical outcomes or logical values. So we want to know whether it's true or false. We want to know whether an outcome happens or it doesn't happen, right? We want to know whether the independent variable influences the existence or inexistence of a particular outcome. And that is a logistic regression. Sort of, it assumes the name of logical values, true or false, right? So we're going to be starting with a simple regression or a bivariate regression where we have just one explanatory variable and one outcome variable or one dependent variable. And as we move on, we're going to look at multivariate regression analysis as well. In this lesson, I'm going to be using the World Development Indicators from the World Bank. So the World Development Indicators is a compilation of several on economics, politics, development, and so on and so forth. And it's very, very good to really understand how regression works, but you could use any data set you want. In the World Development Indicators data set, I'm going to be using two variables. The first variable I'm going to be using is a GDP per capita variable, gross domestic product per capita. And that is going to be our independent variable. And I'm going to explain that shortly. And then we're going to have another variable, which is health spending, right? How much countries spend on health. And that is going to be our outcome or dependent variable. And we want to study the relationship between these two variables, try to see if we can make some causal inferences or make predictions in the dependent variable, which is the health expenditure, the health spending variable based on gross domestic product values. So our hypothesis that we are proposing, right, going into this sort of study is that countries with higher GDP per capita would spend more on healthcare. So any country that increases in terms of GDP per capita would spend more on healthcare. That is our hypothesis. That is our intuition, right? So a hypothesis is a falsifiable statement that we make going into a study, and then we want to use regression analysis to test this hypothesis. Now, there's more about hypothesis testing that not covered in this lesson, but as we go on, I'm going to bring up the most important things about hypothesis testing. So in our lesson, we are interested in three things. The first thing is that can we predict how much a country will spend on health at GDP per capita of $6,000? The second thing we want to ask ourselves is that is there a relationship between GDP and health spending? And the third goal of this exercise that we are doing is that how does health spending vary based on changes in GDP values? So once again, let's do this together. Open your R Studio and then let's code regression analysis together. We are in R Studio now, and I have my world development indicators data set opened. The first thing we want to do is we want to load dplyr and ggplot2 packages in R. If you don't already have dplyr and ggplot2, you need install ggplot2 and gplyr, but I already have it on my computer, so I'm just going to load them inside R. And now I want us to have a snapshot of our our data as usual. So I use the head function just to have a snapshot of how our data looks like. Okay, so inside the world development indicators data set, this is how it looks like. So it gives you, the head function gives you the first 5 observations of each column or each variable. Okay, now I know how it looks like. Let's do some descriptive statistics. Let's find out some descriptive statistics of the two variables that we are interested in. Okay, so I have descriptive statistics of the GDP per capita variable, the minimum value, the maximum value, the mean, and all those things. I know a bit more. I know a bit more about the health expenditure, health spending variable also. And okay, so let's go into it. Let's now. It is good to check these descriptive statistics because it helps you find out how your values really look like in sort of in collective terms, right? Going into your analysis, you can keep the median, the mean, the first quartile, and the third quartile all in mind, and it really helps you do very good analysis. We're going to get into that as we go along. Now, the first thing I want to do is that I want to explore if there is any correlation between GDP per capita and health spending. Now, I know that correlation doesn't mean causation, right? But we want to see if there is some sort of correlation at all between these two variables. Do they vary? Now, if you don't know what correlation is basically how do two variables co-vary? How do they move along? How do increases or decreases in one variable lead to increases or decreases in the other variable? Is there any relationship between them, positive or negative relationship, right? So I use the dplyr package to run this code to check correlation between these two variables. So dplyr is so cool. All right, so there's a correlation of 0.54. The more correlation gets to 1, right? So 1 means there's perfect correlation. The correlation is stronger or weaker depending on how closer it is to 1 or closer it is to 0. So now a correlation of 0.54 tells us there's some correlation there, not too strong, but somewhere in between. But we're going to explore this. We're going to explore this relationship further. Now, the next thing I want us to do about this exploration is to use ggplot tool to visualize this relationship in a scatter plot, right? We've seen this code before in my previous lesson on data frames, but I'm going to break it down just a bit more. So with ggplot2, I use the ggplot function. I load in the world data set as my first argument, and with the statistics function, I call in my independent and dependent variables. I add geom point. What geom point does is that it gives you the scatter points, and I give my figure a title. I name my independent variable and my dependent variable. Now, if we run this code, this is what we're gonna get. We're gonna get a scatter plot of GDP per capita and health spending. Now, there seem to be some relationship going here, right? It looks like higher values of GDP per capita are somehow correlated with health spending. Let's go deeper into this and then see what we can find. Now let's fit a line in our scatter plot to have a much more deeper understanding about this relationship. So we're going to use a similar code as we did before, just that in this particular code I include a new function called geom_smooth. What geom_smooth does is that it adds a linear trend line to your scatter plot to sort of help you trace the path of this correlation. But what this line is actually doing is that this line is utilizing the least squared difference between our fitted values and our predicted values. We're going to talk about that shortly. But if we look at this new graph, it looks like there is some correlation going on here. It's not too good, but we're going to explore this relationship further and see the extent to which GDP per capita is correlated with health expenditure. Let's move back to our PowerPoint presentation and explain what just happened here. I hope you're able to code alongside with me. What we just did was, first of all, we checked whether there was some correlation between our two values, and we got about 0.54. So we showed some sort of correlation, but not a stronger correlation. We used a scatter plot to map out this supposed relationship. And then the last thing we did was we added a trend line, or we added a regression line to our scatter plot. A linear regression line has two characteristics. The first one is the intercept. The intercept is the value of y when x is 0, or the value of the outcome or dependent variable, assuming that the independent variable does not exist. So minus the independent variable minus the explanatory variable, what is the value of the dependent variable? What is the value of our outcome variable? What is the value of our y? So these, I'm going to be using these three terms synonymously: outcome variable, dependent variable, or a y. Outside our explanatory variable, what values do we have for our dependent variable? And that is the intercept. So the slope is the values of y, or the values of our outcome or dependent variable, when our independent or explanatory variable, or our x, increases or decreases. In other words, how much influence the independent variable. So in other words, how much influence the independent variable has on the dependent variable in terms of numbers is our slope, right? And this regression line we fitted is characterized by these two things. The formula for this equation is y hat equals b0 plus b1x, where our y hat is the value that we are trying to predict, which is our outcome variable, or our dependent variable, right, for a given value of our independent variable or our explanatory variable. Now, the B0 is the y-intercept of our regression line. In other words, when x is 0 or when our explanatory variable doesn't exist, what is the stand of y? What is the status? How is y like? How is our outcome variable like when the explanatory variable doesn't exist, right? And that is our b0 is going to be our intercept. And there's a b1, which is our slope, as we mentioned, which is in terms of numbers, how does our explanatory variable influence our dependent variable? And then the x itself is the independent variable or the explanatory variable. So that is very, very simple. Why do we have to fit a regression line? All right. So we're gonna have regression models, and when we sort of plot this, we fit a regression line in our scatter plot. And the reason why we are doing this is we want to find the best fit through our data points that minimizes the sum of the squared differences between the actual y values and the predicted y values based on the x values. Now let me break this down. We want to predict some values of our outcome variable or our y variable depending on the relationship that x and y has, or the relationship between our independent and our outcome variable. If that is so, then we need to first of all know what values exist, which are our fitted values. And secondly, we need to make some predictions based on our fitted values or our actual values. Now, since our predictions can be wrong, it can be a bit far away from our actual values, we are not magicians. We don't know what is actually going to happen. We need to find out how do we have predictions that are most closer to the actual values. So in other words, we want to fit a line that gives us the best least difference, that gives us the shortest error between what we are actually observing in the real life and the predictions that we are making about these x and y variables. That makes sense, I guess. Now that we understand why we plot a linear trend line in our scatter plot, let's build a statistical model that shows us this linear trend line in statistical terms, or that gives us some numbers about this relationship between x and y. Let's go back to our R code and do this together. How do we model this scatter plot with a trend line that we just did using ggplot2? This is what linear models is all about. So we're going to build a simple linear regression model that helps us understand the relationship between x and y. To do that, you simply call the function lm. You simply call the function lm, and the first thing you want to include as an argument is your outcome variable or your dependent variable or your y. Now use a tilde. This tilde sign just shows that, okay, the relationship between something and something else. And the next variable is your explanatory variable, which is the independent variable. You bring a comma and then you include your data set. Very simple. This is a simple statistical model that is going to help us understand the relationship between GDP per capita and health spending. So this is what we get when we run a linear model in R for a bivariate regression or a simple regression. Let's go to our PowerPoint and break this down to really understand what is actually going on here. So when we run our linear model using the lm function in R, this is what we got. We got some output that gives us coefficients. Our linear regression model. So we've run our linear regression model in R using the lm function, and we've gotten this output. Let's break it down. We have two values, one under the intercept and one under GDP per capita. Let's remember our goal. Our goal is to be able to predict how much would health spending increase with increases in GDP per capita, right? Or decreases as well. So if GDP per capita increase or decrease, how much would health spending increase or decrease? So the value under the intercept tells you how much health spending there is in the absence of GDP per capita. Assuming GDP per capita doesn't exist as a phenomena, how much should we expect health spending to be? We have a coefficient of 2.73. What it tells us is that, okay, this is the starting point of our y variable when x is 0. Now we have quite a long number for our GDP per capita, several decimals. But if you go to the next slide here, what this whole decimals is telling us is that the estimate for GDP per capita is 0.00007154. In other words, when GDP per capita increases, we expect that countries would spend more on health by some 0.00075154 units. But it doesn't end here. Remember, a whole lot of things happen in the world, and this relationship can be confounded by a whole lot of other factors. So there's really the need for multivariate analysis. But before we get there, there's a lot I need to show you about regression analysis, and I'm going to do that in the next lesson. This is not really a big number, but it sort of confirms what we found moving through our analysis using correlation and even plotting our scatter plot. But remember, in the real life, several other factors can confound this relationship. So there's the need for multivariate analysis and some sort of theory building to understand what is actually going on here. So there's more about regression analysis that I need to show you that I cannot cover in this lesson. So please subscribe and expect that very soon I'm going to be dropping more lessons about regression analysis. We're going to be building on what we've learned today and see where it takes us and how much we get to know about doing regression in R. See you in the next lesson, and it was nice having you here. Bye.